Hello, students. How's it going? Welcome to Monday's lesson. So we are beginning a new topic in math for the next couple of weeks. Actually, for the rest of the semester, we're going to be doing geometry, which I think many of us will be excited about. And this next topic is going to be on transformations. And so a transformation means when you are changing something. And so for the next couple of weeks, we are going to be doing transformations of geometric shapes. And so before we get started with that, though, it's important to conceptually understand what we actually mean when we're talking about transformations. And we're going to have a fun activity today. When a teacher tells you it's fun, you know it's going to be fun. But we're going to be looking at this Squishmallow cat that I have right over here, and we're going to be making some changes to it. So for starters, let's say that I've got it set up on this table right over here, and I decide I want to move it to this shelf. Well, if I was doing this in the real world, I would just pick it up from the table, move it to the shelf. I do it all the time. I don't need to think about counting. Okay, I just pick it up and move it. But if I'm trying to show that mathematically, I need to be a bit more precise. And so what I would do is I would actually do the first kind of transformation that we're going to learn about today, a translation or a slide. A translation or a slide is where you take a shape or you take an image or a figure and you either move it left, right, up, down, or some of those. So you could move something both left and up. That would be a translation or a slide. I'm going to translate this to the right because my shelf is to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right. And you can count to go from point B to the other point in the gray area. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you were to count from point A to the other point on the white area, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I translated the figure of this Squishmallow cat, I slid every single part of it to the right by 10 units. But it's still not on the shelf. What do I need to do now to move this Squishmallow from here to on top of the shelf? So I need to move it up. I need to translate it up. How much do I need to translate it up, do you think? So I need to translate it up 1, 2, 3. And now my Squishmallow is on the shelf. And there we have it. So one way that you could describe this translation is 10 units right and 3 units up. We're going to learn later this week some more mathematical ways to describe translations, but for now, you can describe it with words that way. Now, let's look at this. Let's say that this is where my shelf is, okay? And I've still got my Squishmallow cat over here. Describe the translation I would need to do to get my cat, Squishmallow, from here to right here. what would that translation look like? Well, to go from point A to the other point where the white part is, I would have to go 1, 2, 3, 4, 5, 6, 7, 8 units to the right. And I would have to go 1, 2, 3 down. So I could describe that translation or that slide as 3 units right, as 8 units right and 3 units down. Let's check with point B. What do you think the translation for point B is going to be? How far right do you think point B goes? How far down do you think point B goes? So if I count from point B to the other gray point, I go 1, 2, 3, 4, 5, 6, 7, 8 still. And then I go down 1, 2, 3. So I am still, I'll make this shelf a bit more centered. There we go. But I am still moving 8 to the right and 3 down. So when I translate or slide the cat, every single point translates or slides similarly. Now, translating or sliding is only one part of transformations. As a matter of fact, there's a few other kinds that I can do. For example, I can have, and this is actually something you're probably very familiar with, but if you ever look in the mirror, you see the reflection of yourself. That's not actually how you are oriented. Your orientation is a bit flipped. And so to give you an example, let's take a look at my Squishmallow here. Let's say that I want to show the reflection of it mathematically. Okay, so I'm using some nice fancy software. It's got this really cool reflection tool. So I'm going to reflect this Squishmallow around or about the y-axis, and look at that. You can see that it is no longer the same orientation. Now, what do you notice about the distance? What do you notice? And I'll even put, if I can find it, I'm going to hide those labels because I don't want to get into that in this video. What do you notice about the point B and the point next to the gray section? How far away are they each from the y-axis? What do you notice about point A and the other point by the white part? How far away are those points from the y-axis? So the distance between the point and the y-axis is still the same. It is still 7 to go from point A to the y-axis and 7 to go from the y-axis to the other point by the white area. And it's still 5 to go from point B to the y-axis and from the y-axis to the point by the gray area. But the cat is now flipped. The pink ear used to be in the left corner. Now it's in the right corner. This gray spot used to be on the bottom right corner. Now it's on the bottom left corner. That is a reflection. When you flip the orientation of a figure. We're going to get into a lot more mathematical and precise descriptions of this later, but for now, what you need to know is that a reflection is a flip. And it's not always necessarily about the y-axis. So look right here. I can actually flip or reflect this figure about the x-axis. And so the pink part used to be up, now it's down. The gray splotch used to be on the bottom part of the cat. Now it's at the top part of the cat. And so there are multiple different ways that you can actually reflect. This year, we're mostly going to be focusing on reflections of the X and the Y axis. Now, there's one other kind of rigid transformation that we can learn about. And let's see, will that delete it? I didn't want to do that. Let's see. There we go. I'll just undo it. That works. There's one other kind of transformation that we're going to learn about. Okay, and that is called a rotation. Now let me zoom this out a little. Now, move this down. Okay, I've got my Squishmallow right over here. But sometimes my partner likes to throw them because occasionally she likes to act like a preschool boy. And when she throws them like a football. And if you've ever seen anyone throw something like a football, the way it usually goes is like this. And as she's throwing it, let me move this around. As she's throwing it, the shape isn't moving like this, or the Squishmallow isn't being thrown like this. That's not quite how it works. The Squishmallow is being thrown a bit more. Let me erase this flight path real quick. The Squishmallow is being thrown a bit differently. So I'm going to go down here, and we are going to be rotating this circle. And we're going to rotate it 90 degrees clockwise. And you can see here that is a bit more like how my partner likes to throw the Squishmallow. And so you got that upward trajectory, and then it goes down here. And so then by the time it falls, the head is no longer up. Now, let's go down here. I am going to be rotating this, not just 90 degrees this time, but 180 degrees clockwise. And you can see that's kind of where it ends up, on the ground face down. So that right there is an example of a rotation. In a rotation, not only is the location changing, but the orientation is changing as well, the direction of it. So here we've got the pink ear up. Here, though, we've got the pink ear sideways on the right. And now here we've got the pink ear down at the bottom. And so rotations, they are one of the 3 rigid transformations that we are going to be learning about this year. Now, rigid means hard or not changing, and that might seem a little weird because transformations mean to change something, and rigid means hard, not really changing. So why do you think that a translation or a slide, a reflection or a flip, or a rotation, which I don't think I said, but we can think of that as either a spin or a turn, why do you think those 3 things are called rigid transformations? Let's notice something. As I rotated this 90 degrees clockwise, I changed the location, I changed its direction or orientation, but did I change the size of the shape? If I look at the size of this Squishmallow, it is still the exact same size here. And if I look at the size of this Squishmallow, I can see it's the exact same size as this Squishmallow. And I could see not only because if I zoom in, you can see I've got my coordinates at -7 and -5. If I go up here, I've got 7 and 5. So that distance is still 2. So I've got here a distance of 2. Here is a distance of 2. And here's a distance of 2. So the shape itself didn't actually change. The size of the shape didn't change. The other thing that didn't change is the position of the different points. The different features of the figure didn't change. So my pink ear was to the left of the gray ear. And now the orientation has changed, but I still have the pink ear now above the gray ear. The gray ear didn't suddenly go onto the left side and the pink ear didn't suddenly go onto the right side. So the figure stayed the same size and the figure's shape stayed the same. And if we look back at reflections, so let's say that I wanted to go ahead and clear this all, and I'll even erase this. If I do a reflection again, or a reflection. If I reflect this, let's say again about the y-axis, you can see that I did not change its shape, and I did not change the shape itself. So I still have the pink ear, the gray ear. Now this time, the gray ear is over here, but the entire shape reflected. So every bit of it reflected. It wasn't like part of the shape reflected and the other part didn't. The whole thing reflected. So the shape itself still stayed the same. It's just oriented differently. And if I think about my translations, I won't bother with that. But if I think about my translations about moving, I don't want to deal with that. There we go. But if I think about moving this, there we go. You can see again, I didn't actually change the shape itself, the figure, and I did not change the size of the figure. I just changed its location. So that is what we call a rigid transformation. So a rigid let's see, does this have... Nah, that's okay. So a rigid transformation. Okay, and that would take too long for me to spell out. So I'm just going to do this. And rigid transformation. Examples. We've got reflections, okay, and we can call those flips. We've got rotations, and we can either call those spins or turns. And we have got translations, and we can call those slides. And so a rigid transformation is a change that is a change to a figure's location or orientation, okay, and that's kind of like direction, that does not change the figure's shape or size. Those are the three kinds of rigid transformations that we have: reflections or flips, rotations or spins and turns, and translations or slides. Now, for your work today, you're going to be finding examples of the 3 rigid transformations, which again, today I just went over a very brief introduction to the 3 rigid transformations. We're going to be getting a lot more information about them on Tuesday. But today, I want you to use the basic knowledge that I've given you about reflections, rotations, and translations, and find an example of each in your home. So I'm going to show you, here's the work. Okay, so you are going to be finding the 3 rigid transformations at home. You can check out my example, and I'll go over that real quick. You need to make sure that you are describing why it is an example of a rotation, reflection, or translation with words and a picture. Make sure to place arrows and lines as needed to demonstrate the transformation. Okay? If you want an example of how to take a picture with your Chromebook, here you go. How to insert a picture into Google Slides, here you go. And how to place arrows and or lines on a Google slide, here you go. Let me know if you have any questions. So again, I'm not available on Mondays to help because Mondays are a teacher work day and I have a lot of meetings. So here I'll show you. You put your picture here and then you explain what did you choose as the example and then describe it. That's important. In a complete sentence, describe how what you chose is an example of a rotation, or describe how what you chose is an example of a reflection, or describe how what you chose is an example of a translation. Let's take a look at mine. So I think I've shared with class, I used to work in a bakery and I still decorate cakes quite often for friends and family. A couple months ago, I made a nice one for my dad's birthday. So anyways, I have a cake wheel. And what you do is you plop the cake on here and then it makes it a lot easier to decorate. And you can see that I showed on here what it is that it is rotating. Okay, I drew the green arrow to show that it spins. And not only that, but I drew this green dot here to show that it rotates about the center. That's how we say it. You rotate about the center, okay, or about something else. But that's the math phrase. You rotate about, and then whatever it is, you're rotating around, okay? And so I put here, I chose my cake wheel. And then for my description, I said my cake wheel rotates about its center, which is very useful for decorating cakes. That is not a huge sentence, okay? It's not a paragraph. It's fairly simple, okay? That's okay. That's all you need. Now, I've given you here an example of a bit more descriptive. Okay, this would be kind of like an exceptional, above standard response. So I got a little blue llama squishmallow, which is a little stuffed animal here. And you can see that normally it's got a little tag here on the right, but in the mirror, its reflection shows that it's on the left. So that would be an example of a flip or a reflection. And I wrote, its reflection in the mirror shows a flipped version of the blue llama. Notice how the little tag is on the right side when I am holding it, but on the left side in the reflection. And you can see here, I drew a line to show the halfway point, what it's reflecting about. Okay, so if you think back when we were dealing with the reflections, okay, I said you could either reflect about the y-axis or the x-axis. So here I'll show you, you can reflect this about the y-axis, or you can reflect the shape about the x-axis. So there is that line, which we're going to learn about later, that it reflects about. So I tried to draw that. And then I even drew arrows to show, look, see the feature flipped. And lastly, this is an example of a rather simple description, but it's effective and it works. I took a picture of my front door, which is a sliding front door. And I drew an arrow here to show that it can slide both left and right. So that would be an example of a translation. Okay, and I just wrote, my front door slides left and right to open. Pretty simple, but that's effective. That's all I need. So hopefully the idea of rotations, reflections, and translations is making a little bit of sense. Hopefully you have a lot of questions. If there's some parts you're confused about, good. That means that your brain is learning. Confusion is good. If you're feeling confusion, that means that your brain is trying to learn this new material and trying to make sense of it. I'm here to help you make sense of it. Okay, this is just the introduction, but there's going to be a lot more that we're going to be learning about in the coming weeks. So I'm going to end this video here. I want you now to take some pictures. Like I said, I've got all these videos here to help you out if you need that support. So use them and have a wonderful rest of your day.